everyone, and welcome to Infratex Environmental Services Webinar Session 1 entitled Overview and Best Practices of Jointless Steel Fiber Concrete in the New Normal. My name is Janelle, and I'll be the moderator for this session. First, we are glad that we have you all here today despite of your busy schedule. So we hope you will find this webinar valuable and interesting. So before we begin, please be reminded to mute your audio and turn off your video to avoid interruptions. If you have questions, you're welcome to type them on the chat box and we'll bring them up during the Q&A session. This session will be recorded. You will also receive an email with the presentation slide as soon as we have it ready for you. I will also be administering a few feedback questions. E-certificates will be available upon request, and I'll also send the survey and e-certificate request links into the chat box before the session ends. Also, we would like to invite everyone to connect with us on our social media accounts, Facebook and LinkedIn. You may follow us and get updated on the latest news and events. For questions or inquiries, you may contact us at sales@infratexenviro.com or through our mobile and telephone numbers. You may also visit www.infratexenviro.com to know more about our products and solutions. Joining us today is Engineer Monikka Tadeo and Engineer Gilbert Ancheta. Engineer Monikka graduated with a degree in civil engineering from the University of the Philippines. She is a licensed civil engineer with extensive experience in concrete reinforcement. Currently, she is a technical business development engineer and been with Infratex Environmental Services since 2019. Our next speaker is Engineer Gilbert Ancheta. He is a licensed mechanical engineer and he graduated from Polytechnic University of the Philippines. He has extensive experience in the implementation of various projects from delivery, installation, testing, and commissioning. Currently, he is Infratex Sales Engineer for Jointless Steel Fiber Concrete Reinforcement. So that's it for our introduction. I will now turn the time over to our speakers. Hi, Monikka and Gilbert.
Hello, good morning.
Okay. You may now share your screen.
Okay. Visible na po yung screen ko?
Yes, Monikka.
Okay, so good morning, everyone. So I would like to thank you all for attending this webinar. And this morning, I will be discussing the overview and best practices of jointless steel fibers in the new normal. Okay. So just a few background with our company IESI. So Infratex Environmental Services Incorporated was formed in 2011 under the flagship of Macaferry Group. So we've been together with Macaferry Group for about 30 years already. So our company continued to grow, expanding its range of products to provide engineered environmental solutions. So we actually have three partners. We represent Beckart, Payco, and Solmax here in the Philippines. Okay, so for our agenda for today, first I will introduce Beckart and Payco. So next would be the application of ceramic steel fibers, how ceramic steel fibers work, how Payco armor joints work, and the benefits of steel fibers and armor joints when used together. So the question and answer would be at the end of my presentation. So our first partner would be Beckart. So it is a global company which is the world's largest independent manufacturer of drawn steel wire products. So with Beckart Steel Fiber, we have been offering solutions for warehouses, for industrial floorings, in using steel fiber reinforced concrete. This one addresses several flooring issues such as cracks, spalling, and abrasion. So another partner of our company is Payco. So it is a Finnish company that supplies a large selection of concrete connections and composite beams. So they are the one that supplies our armor joints, dowels, and sleeves. Okay. First off, I would like to introduce steel fibers. So what are steel fibers? So dramix steel fibers, it basically replaces your typical reinforcement bars used in reinforced concrete in slabs, used for industrial floorings, precast, tunnel, and residential applications. So this one actually answers to the challenge of crack control. So this will enable you to reduce your maintenance for your floors and create more durable and environmentally friendly warehouses. So this is a picture of how steel fibers look when mixed together with concrete. So this is a picture of a slab, and then this provides superior resistance to cracking and crack propagation. So our fibers are evenly distributed throughout the concrete. So every part of your floor is actively reinforced. So this will allow them to detect small cracks immediately after they occur. So yeah. Um, this one, so this is a picture of how steel fibers bridges the growing cracks. So steel fibers in concrete primarily act to bridge the growing cracks. Thus, it restricts their further growth and propagation. Okay, so we actually have three different types of steel fibers that we offer depending on the strength you need or where will it be used. So dramix steel fibers reinforcement features unique hook ends, so it actually have different hook ends, tensile strength, and ductility. So for our 3D fibers, we have 1,270 Newton per square millimeter of tensile strength. For our 4D fibers, we have 1,650 Newton per square millimeter of tensile strength. And for our 5D fibers, we have 2,300 Newton per square millimeter of tensile strength. Okay, so for 3D fibers, we normally propose this to use for administrative buildings of a warehouse. So this one will normally carry minimal loads. So for the 4D fibers, we normally use this for warehouses that will have racking system. Okay, so for 5D fibers, we use it or we propose it to use for slab on piles. Okay, so this results in previously unavailable levels of anchorage and crack control, creating more durable and safer structures. Okay, so now that you know what a steel fiber is, we now go to its advantages. So why do we use steel fibers over rebars? Okay, so number one, it has reinforcing capacity and efficient crack control. So another one would be um, quick and easy application. So when using steel fibers, we actually require less labor and it can save you time and money. So in using a steel fiber reinforcement, the first thing you would do is, the only thing that you would do is to add the steel fibers to the concrete mix and then directly pour it to the area. Okay. And another one for the steel, while in doing the steel mesh reinforcement, you have so much to do. So you transport the mesh or the rebar, handling of the stock of the rebar on site, and then tying or placing the rebars, and then pouring the concrete. So many steps. Unlike for using steel fibers, we just mix it and then pour it directly. Okay, so another one would be it is cost effective. So from experience, conventional slabs with thickness of 200 millimeters, we can reduce it to 180 or even below. So there will be a reduction of slab thickness and cheaper floor for a given load. So normally for traditional slabs, we have concrete cover, normally 40 millimeters. So for steel fibers, we don't need to use it anymore. So we can reduce the slab thickness. So next would be it is easily mixed. Okay, so dramix steel fibers are glued in bundles, which enables fibers to be mixed easily and uniformly throughout the concrete. So our fibers comes in glued bundles, and then it will scatter throughout the concrete during mixing. Okay, so where to mix the fibers? So it can actually be mixed in two ways. So number one would be it can be mixed through concrete mixer, and another one would be batching plant. So we'll just advise the rotation and the speed required in mixing the fibers to the concrete mix. So it depends on the availability of the concrete mixer or the batching plant. So whichever is convenient. Okay, so this one is the difference between the glued fibers and the loose fibers. So as I've said earlier, ceramic steel fibers are glued fibers. Okay, so why? Because it is found to perform better. So loose fibers can have problems such as balling. So in using glued fibers, you just pour it directly to the concrete and then it will scatter through the concrete mix. So we will avoid balling during mixing. Okay. So just to add another one, so even when steel fibers corrode, due to the geometry of our fibers, the corrosion produced does not exert enough stresses to the cracked concrete. So unlike in rebar, it is a concern. So dire-diretso yung pagka corrode ng rebar. Unlike our steel fibers, hindi siya dire-diretso kasi hiwalay siya. Okay. So I'll just show a video of how ceramic steel fibers work. So this is basically a summary of steel fibers when mixing and then pouring. Okay. Sorry, wait. Okay.
Steel fiber concrete reinforcement has been around for many decades. They meet local and global standards and are often the best reinforcement in terms of safety and cost efficiency. Steel fibers benefits applications of various sizes and designs, from structural applications such as foundations to non-structural applications such as floors. Take concrete flooring. Why put time and effort in installing mesh if you can add the reinforcement directly to the concrete? Here's how it's done. Of all components, add the fibers last to the mixer. Add them gradually at a maximum dosage rate of 80 pounds per minute. Mix for at least 5 minutes at the highest drum speed. You can pour the concrete either directly or by pump. The fibers are glued in bundles that gradually release during mixing, dispersing evenly through the concrete without balling. Just make sure you pour in a dry environment, on a well-prepared underground, and within an hour of mixing. Vibrate the concrete immediately and thoroughly after pouring to avoid fibers at the surface. Ensure hardness by applying a dry shake hardener and troweling until you get a mirror-like finish. Finish off with a curing compound to avoid drying, shrinkage, cracking. The final properties of your structure not only depend on the type and dosage of fibers in concrete, but also on how you mix them together. To help you calculate the optimum concrete mix, you can rely on reputed design programs like our in-house developed Dramix Pro design tools or finite element software like SIA or Adapt. Would you like to know more on Dramix? Visit beckart.com/Dramix.
Okay, so I hope you learned something from that video. So that is basically the summary of how steel fibers work. Okay. So we actually have 3 different floor types or applications in using steel fibers. So we have socket joint floor, jointless floor, and seamless floor. So first, I will tackle socket joint floor. So this is what we call long strip casting method. So this method would use construction joints and sockets every 6 meters, as seen on the photo on the left. So in advantages of using socket joints, so you will have consistent joint dimensions, which has the same width and depth at each cut. So you will have straight and clean cuts, and it will be cost-effective concrete placements of any size, and then no random cracking because yung pinaglagyan mo ng socket joint, dun mag-propagate yung ating mga cracks if ever man magkakaroon. Okay, so for the jointless floor, or what we call large bay casting, so the photo on the left, it will have no more contraction joints, no sockets every 6 meters, or wala na talaga siyang socket joint. And then we have special joint profiles at large distances up to 50 meters. So the photo on the left could be 20 meter by 20 meter. And based on our experience, we've casted maximum of 24 meters by 24 meters. So there. So ano ba yung mga advantages ng using jointless floor? So you will have lesser joints, lesser source of maintenance problems. It will be low maintenance, and then faster construction compared to socket floors. So putting off joints will be lesser. For the seamless floor, this is what we call the combi slab. So combi slab would have no more socket joints, no construction joints, but this will be the combination of steel fibers and rebars. So this will be of continuous pouring. So first would be tying of rebars, and then saka natin ipupour yung steel fibers together with the concrete mix. Okay, so wala na tayong mga gagamiting dowels or mga armor joints with this type of application. So what are the advantages in using seamless floor? You will have extreme durability, high serviceability and low maintenance, high speed lift trucks, and then yung quality is okay. So this is a test certificate of our tensile strength for our Beckert Dramix 3D 8060BG and our Dramix 4D 6560BG. So it shows that yung kiniklaim naming tensile strength is true based on the test, and actually twice of the rebar strength. Okay. So this one naman would be the sample of our technical computation. This is our technical design dosage. So this one actually shows the design for your slab. So it consists of the thickness of the slab, the dosage, which is in kilograms of steel fibers per cubic meter of concrete. So it also shows the floor type and the maximum joint that can be used. So the concrete class, and then ayan, if you will use only fibers or if you will also use rebars together with fibers. Okay, so the picture on the right would be the loads and location of the uniform loads, point loads, and distribution loads. Okay. So, as I've said earlier, we actually have two partners, Beckert and Payco. So Beckert for the steel fibers, which I have tackled earlier. And now I will discuss Payco for the armor joints. So what are armor joints? So we call it Terra joint. So it is a free movement joint for industrial floor slabs. So it is a leave-in-place floor joint system used for jointed and jointless ground-supported floors and pile-supported floors. So this can hold up to joint openings up to 20 millimeters. It also allows 10 millimeter of lateral and 20 millimeter of perpendicular movement. So Terra joint is actually the permanent formworks during your concrete pouring. So this will be the replacement for your wooden or steel formworks. So this is designed to build free movement joints. It consists of heavy-duty iris armoring and a load transfer system. So I will show you a video later that shows the load transfer system of the Payco armor joint. So our armor joint is available in plain steel, hot dip galvanized finish, and stainless steel. So it actually have three different types. So our system offers a solution for all operational environments. So in using armor joints, you will have easy installation with assurance of levelness. So you will just have less labor and time in achieving a flat floor. Okay. So this is the video of how Terra joint works on the site. So I'll just play it. And the last part shows the load transfer system of the armor joint. So that is when the forklift passes and then load transfer system. Okay, so our armor joint comes in different sizes depending on your slab thickness. So our armor joint comes in 3-meter length and the dowels in it. So it has 500 millimeter center to center spacing. Okay, so we normally recommend having 15 millimeter difference from the slab thickness to the height of the terra joint. So example, if you have a floor having a height of 200 millimeters, we will propose using the 185 millimeter terra joint. So why is that? So the difference in height will enable the concrete to have space when it expands. Okay, so we have different types of armor joint depending on your desire. Okay, so from 90 millimeter to 245 or even special sizes. So we actually have 3 dowel types, which are 6, 8, and 12 millimeter thick. So this is also depending on the joint opening requirement. So for joint opening from 0 to 15 millimeters, we advise to use only 6 millimeter thickness. So for 15 to 20 millimeters of joint opening, we will advise to use the 8 millimeter thickness. And beyond 20 millimeters, it is advisable to use the 12 millimeter thickness dowel. Okay, so we actually use our rectangular dowels now. So on the video, it is oval, but now we use rectangular because it has higher area. Okay. So just to share with you the project references that we've done through the years. So this one is Japan Tobacco International in Batangas. So the year of construction would be in 2017. Total floor area of 48,000 square meters. And the ceramic steel fibers used is 3D. Okay, 3D of 80-60 BG. Okay, so 80-60 would be the diameter and length and diameter ratio. Okay, so the Peco armor joints used is 185 in height, and then used a 6 millimeter dowel. So this is how it looked like on the site. So they used big bay casting. So they used jointless floor here. So from what I can remember, it is of 20 meters by 20 meters in size. Okay, so another project we've done is Nestle Warehouse in Tarlac. So it was done in 2019 with a total floor area of 33,000 square meters. We used Dramix 3D with a total of 105 metric tons. Okay, we also used 185 millimeter of armor joint and 6 millimeter of the dowels. So here in Nestle Warehouse, we use a combination of terra joint and terra dowels for their big bay casting. So for this project, they casted 24 meters by 24 meters big. Okay. So this is our ongoing project, Southern Star in FIT Santo Tomas, Batangas. It started in 2020. So the total floor area is 45,820 square meters. They used a combination of Dramix 3D and Dramix 4D. So for the 3D, they used it for their administrative buildings and yung mga maliliit lang yung i-carry na loads, wherein they use the 4D fibers for their warehouses that will carry their racking system. Okay, they used 175 millimeters because their slab thickness is 190 millimeters. So they also used 6 millimeter dowels combined with the terra joint. So they also use a combination of dowels and armor joints for their project. So this project is a combination also of jointless floor and strip casting method. So the picture on the right is their picture of one of their warehouse that used strip casting method, 6 meters. Okay. So just to summarize everything we know and we've learned today, so the principle of steel fibers reinforce concrete and armor joints in a nutshell. So number one, we will have eliminate the traditional reinforcement. So you will have no more rebars on your construction. So you will have results. It will result in a faster and safer construction. So number two, you will have homogeneous distribution. So it will have uniform reinforcement of your concrete structures. Another one would be redistribution of stresses. You will have high ductility and increased load-bearing capacity. So another one would be excellent crack control. So a significant reduction of concrete cracking and spalling of segments. So you also have optimal resistance against impact and dynamic loads. In using large bay casting, you will have significant reduction in construction time, and you will have savings in maintenance costs and have the best ARIS protection at construction joints in using large bay casting or jointless floor. Okay. So uh, due to COVID pandemic now, we are now restricted and much more careful with construction. So we have limited workforce at job sites. We will observe tighter screening, safety and health measures on site. Okay, so that's why we offer alternative solutions in using steel fibers and armor joints to have less labor. Um, Tying of rebars will be eliminated. Thus, we can save time and cost. With the concrete being reinforced with steel fibers, concrete cover added in typical reinforced concrete will also be eliminated. So we will produce a thinner and cost-efficient floor. So also in using steel fibers and armor joints, especially in using armor joints, you will have ease of construction and application. So that's what we can offer in using our products. So that ends my presentation, and if you have questions, you can ask now or later after Gilbert's presentation also. Okay, so thank you for listening.
Thank you, Monica, for your informative presentation. So I hope everyone learned something valuable on it. So we will go ahead and take some time for a question now. So just a reminder, please be sure to type your questions into the chat box. Okay, so if ever, you may type it on the chat box, and now we will now proceed to the next speaker. Okay, our next speaker is Engineer Gilbert, who will present about the steel fiber reinforced concrete floor casting methodology. Hello, Gilbert. You may now start sharing your screen.
So, good morning, everyone. So this would be a brief presentation regarding the construction methodology of steel fiber reinforced concrete floor. So actually, a more detailed presentation will be part of the succeeding session. So we encourage you to join also the session 2 and 3. So for the meantime, for this presentation, it would include the casting process from the preparation of the soil, terra joint and terra dowel installation, the dosing of steel fiber in concrete mix, wash out and slump test, pouring of steel fiber concrete, reinforced concrete, other concreting process, and at the end we'll also have a question and answer session. So to start, just like any other type of casting methodology, it would start with the preparation of the soil. So the sub-base must be prepared in accordance with the project specification, and the soil must be well compacted. So as we know that the credibility of slab on grade is highly affected by the conditions of the soil. So remember, for a backfilled subbase wherein you do that in layers, each layer must be compacted as required on the specs. So for example, we have here a 3-layer subbase, and the specification requires that this soil must be compacted at 95%. So each layer, 1, 2, and 3, must be compacted 95%. Not just the exposed or the top layer, not just the bottom layer, but all of the layers. Then the next point would be to make sure that the soil is flat as much as possible. So good thing here actually in the Philippines is that mostly of the flooring constructors and the general contractors follows a more stricter protocol in terms of flatness tolerance. Many of them actually, and maybe some of you guys follows plus or minus 5 mm, which is actually better. But for the sake of consistency within this presentation, allow me to use plus or minus 10 millimeters because it follows the range wherein the TerraJoint can perform. So the next point is to make sure that the subbase is dry and there's no water punch. So of course, we don't want excessive moisture to penetrate the slab and cause corrosion on the reinforcement. So as you can see here at the bottom picture, it's actually taken from one of our project in Batangas. Supposedly, it was the first day of the concreting activities for the contractor. However, due to heavy rains the other night, the rain entered the building and created water ponds. So at their discretion, we decided to postpone the concreting in order to rectify the wet subbase. So here I have a sample of a perfectly prepared subbase. So as you can see, the soil is dry. There's no water punch. Even if the mixing trucks travel within this area, there's no risk of creating depressions or rotting. Also, open areas are temporarily closed to protect the soil, plus the freshly concreted slab from the rain. And also it acts as wind barrier. It's also a good practice to use plastic film sheet as an extra layer of protection against moisture, and it lessens the friction between the soil and the slab when the slab started to shrink and move. So the next step would be the TerraJoint and TerraDowel installation. So here I have two samples of a joint layout for a similar warehouse building. So the left one uses a combination of TerraJoint and TerraDowel, while the right one uses a full TerraJoint system. So the green lines represent TerraDowel and the blue lines represent TerraDowel. So mainly TerraDowels are placed on less critical joint areas like joints underneath the racking system. So this is the racking system. Joints wherein there's no forklift that cross. Joints or areas wherein most of the load comes from foot traffic only, like offices, admin buildings, something like that. So this would be given to the clients for their approval, and once approved, that should be followed as close as possible. And the height, the location, straightness, squareness of each TerraJoint line must be diligently checked. That's very important. And to help us guide on the right location, the height, and the straightness, we can use string lines. So that's very convenient to use. So as mentioned on the previous presentation by Engineer Monika, the TerraJoint height is normally smaller compared to your slab thickness. So the slab, if your slab thickness is 200 mm, your TerraJoint height would be 185 millimeters. So the reason behind that is to maintain a 15 mm plus or minus 10 mm gap between the TerraJoint and the subbase. So this is where the flatness tolerance comes from. So if you install the TerraJoint like this, wherein the soil touches the bottom of your TerraJoint, what it do is it blocks or it hinders the movement of the slab during the natural concrete shrinkage, and normally it results to the separation of the areas of the slab to this area, top strip. So what it makes is it makes the areas now prone to damages, which we don't want that to happen. Now, since there is a gap between the soil and the TerraJoint, there's a risk of overflowing of concrete. So it's a must to remove that overflowed concrete when it is still wet, or we need to chip up hardened concrete, which would be time consuming. So what we recommend on our previous project is to use materials like pipes, timber from the pallets, or sand to temporarily block that gap. So after the concrete hardened, just easily remove the material. So it would be like this. So in installation of TerraJoint, we have a device called TerraFix. So it basically makes the installation of TerraJoint quicker and easier. So it has several features. At the top, it has a bolt that controls the height of the TerraJoint. And at the middle, it has a pin that goes into the slot on the TerraJoint, and we inserted that pin on these support tips. So now since the TerraJoint is mounted on the support tips, you can control it with the adjustable bolt. And at the bottom, it has a tapered fit to provide stability and easy removal from any solidified concrete. It has also a vertical block here that serve as support on the TerraJoint once mounted on the support tips. At the rear, it has a hole to allow insertion of pins and a bolt to lock in the TerraFix and TerraJoint in place. Right. So normally, per piece of TerraJoint, we need 3 pieces of TerraFix. So 1 at each end and 1 at the middle. Now, casting a very large bay, say 30 by 30, would require a lot of TerraFix. So approximately that's 120 pieces. Now, to limit the number of TerraFix, we adopt another method of using rebar pins. So basically, we use 2 TerraFix at each end, then have the TerraJoint adjusted to the correct height and straightness, and in between we install pins, rebar pins. Just remember in using pins, not to weld directly on the top strip, to the dowel or to the sleeve or divider plate. We can only allow fixing or welding of pins into the studs on this portion only, and it should be in between the dowels or the sleeves. So no pin should be in front or facing the dowels or sleeve. So now the next step is the Terra dowel installation. So first, it could be screw type if you have steel formworks, or nail type if you have wooden formworks. Then you have to mount the sleeves on your formwork at a center-to-center distance of 500 mm and a height equal to 1/2 of the slab thickness. So after the concrete hardened, just remove the formwork, then insert the dowel. And the other bay is now ready for the pouring. So now since you installed the Terra dowel and TerraJoint, the bay is now ready for concrete pouring. The next step would be the dosing of steel fibers either at the batching plant or concrete mixer at site. Still, we recommend to do that at the batching plant through the conveyor and central mixer because it will allow us to dose and achieve the uniform distribution of steel fiber a lot faster. However, if the situation requires us to do that at site, we can do that at the back of the mixing truck. Just remember that the drum speed must be at high speed, and after completely dosing the steel fibers, continue mixing up for at least 5 minutes or 1 minute per cubic meter of concrete. So if you have 10 cubic meter of concrete in the mixing trucks, continue mixing for 10 minutes. Then after that, we do washout test. So washout test is to determine whether the steel fiber is uniformly distributed within the concrete mix. So this is based on British Standard EN 14721. So what we do is we take 3 random samples to a 5-liter bucket. Then we separate the steel fibers from the concrete mix by vibration, washing out the mixture, then picking out the steel fiber with magnet, then washing it again. Then we weigh it. The allowable result must be within plus or minus 10% to allow the mixture for pouring. So for this specific test, the dosage of steel fiber is 20 kg per cubic meter. So theoretically, the amount of steel fiber for our 5-liter bucket is 100 grams. So after the testing, we recorded a weight of 98 grams. That indicates that the steel fibers are uniformly distributed within the concrete mix. Then simultaneously with the washout test, we can do slump tests. So it would depend on the fiber dosage and on how you will discharge your concrete. So for fiber dosage of 20 to 25 kg per cubic meter, if you do that by direct pouring, your slump must be 130 mm. If you're going to use concrete pump, the slump must be 150 mm. Then for fiber dosage between 30 to 35 kilogram per cubic meter, the slump when pouring it by direct discharge must be within 130 to 150 mm, and while when using concrete pump, it should be 150 to 180 mm. Then last, for fiber dosage between 40 to 45, both for direct discharge and when using concrete pump, the slump test must be 150 to 180 mm. So if your concrete is now ready, the next step would be the conventional concreting activity. So pouring, compacting, and leveling. Now, another advantage of using SFRC is in situation like this. So you have a panel wherein it is adjacent to a freshly concreted panels just 2 nights ago. So there's in no way that your mixing trucks can travel within this area. But when using steel fiber reinforced concrete, the mixing trucks can easily travel within the bay. However, I mean, if try to imagine that you use the traditional reinforcement bar, the most possible way of pouring concrete on this type of uh, application would be by using concrete pump, which would require additional expenses for rental, for the fuel of the concrete pump. So after that, the next step is to make sure that there's no sticking out or floating aggregates and steel fibers at the surface of the concrete. So the best way to avoid that is by using mesh roller. So the mesh roller basically pushes down or depresses the aggregates and steel fibers into the concrete, and it prepares it for the smooth finish. Then the next step would be by bull floating. So bull floating is to further smoothen the concrete surface and remove the surface imperfection. All right. So the next step would be screeding. So in application like jointless design, it is very advantageous to use laser screed because it uses a telescope it automatically levels the concrete using telescopic boom at a rate of 240 square meter per minute. So if you have a large bay pouring, it would require a less time in order to finish your floor. So after laser screeding, this is a sample photo taken from our Nestle project in Tarlac. So the base size is 18 by 20 meters. So the next step, more of the finishing, would be the floor profiling to determine the F-min for the indicated traffic route of the forklift. Then power trolling to achieve a smooth and mirror finish of your slab. So here I have actually a video of the whole process. So right, that would be the whole process. So the end result would be this. So the finished flooring taken from our ongoing Southern Star project. So as you can see, after the 28 days curing period and the floor achieve its required compressive strength, the floor are okay to use as staging area of other materials. And lifting equipment can also utilize the floor. Just make sure to use protective materials like plywoods or steel plates. Another sample of a finished floor. So this is from the Nestle Warehouse Starlock project. So exposed joints wherein normally the forklift pass by uses Terra joint, while joints underneath the racking system uses Terra dowel only for load transfer only. Then the last one is taken from our Japan Tobacco International Flex Facility project. So this is a jointless floor design that uses Jamix 3D and a combination of Terra dowel and Terra joint. So that's actually ends my presentation. If you have questions.
Okay, thank you, Gilbert. I hope everyone found it interesting. So we will go ahead and take some time for questions now. So you may type it on the chat box and we'll bring them up. So I think we have a first question, which we have already, I think we have answered. So first is from Iris John. Is this applicable to flood control mitigation, like concrete flow protection? So we have answered your question like that yes, fiber reinforced shotcrete can be used for concrete slope protection and it will provide a reduction in labor and material. So any other comments from the speakers about the questions of Iris John?
So far, that's actually it. Um,
Okay, thank you. Any other questions? You may type it on the chat box. Okay, question from Donna Arias. Can steel fiber be also used for heavy traffic loading?
yes, actually, it's very recommended to use that on high traffic areas. Um, Mostly, what it do is it reduces the slab thickness. So areas like container yards, loading bays where there heavy traffic of forklift and container vans. So in most of our project, it actually included in that type of application.
In addition, we normally use steel fibers where there's traffic loads, so where the forklift passes or uh, any type of equipment that will pass through the area. So we normally propose to use 4D fibers together with our construction joint, which is the armor joint. So in using this, you will have a protection of your aris uh, for the load transfer system. Okay.
So thank you, Monica. Thank you, Gilbert. So e-certificate request link and feedback form has been posted into the chat box. So don't forget to fill in your request. Thank you. Any other question? We still have more time for additional questions before we end this presentation. Okay, follow-up question. It would not require to have combination of rebar and steel fiber.
Okay, so depending on the loads na i-carry. So normally if kaya na ng steel fiber namin, which is the 4D, what we propose, hindi na namin siya nire-require na haluan pa ng rebars. But then ang ginagawa namin, ang proposal lang namin for combination of rebar and steel fiber for mga cold storages, tsaka yung mga loading bays wherein dun talaga yung high traffic areas and then dun talaga yung mga nagpo-propagate yung mga cracks. Wherein dito sa mga, kunyari, dadaan lang ng mga forklift, ganyan, no need to do the combination of rebar and steel fiber. We just use a higher tensile strength of our fibers. Yan.
Okay, thank you, Monica. And I hope, Ms. Donna Arias, we have answered your question. So, any other question? Okay, I think we're good for now. So, e-certificate request link and the feedback form has been forwarded and posted here in the chat box. So, if ever you have further questions, you may email us and we'll make sure to assist your queries. Okay, yes, another question. For the recorded, yes, we will share the recording through your registered email. So you may check your email after this session for the recording. And make sure to check also your spam and junk folder kasi sometimes doon po nagpo-proceed yung email. So hindi na check yung email. And yes, certificates will be available 3 to 5 days after this session. Oh, so I think we're good for now. Any other comments from our speakers?
Just we have additional sessions for this webinar series, so I think that's May 13 and 27. So we encourage you to also join that an additional series or additional sessions.
All right. So, yes, Monica?
No, wala na. We just want to see you again for our next webinar series. Thank you.
Okay, thank you. I'll be sending an email for the survey and for the presentation link to those who attended today using their registered email. So you may also follow us on Facebook and LinkedIn. So great, thank you everyone. Thanks again for joining us today, and we hope that you join us on our next webinar session on May 7 and May 21. So thank you and have a nice day.
Thank you.
Thank you.